Alright, so today we're going to be going over the quotient rule, which is essentially, let's say we have d over dx, function fx over g of x. By the quotient rule, we would do f prime of x times g of x minus f of x times g prime of x. And then all of that would be over the function g of x squared. So let's get on to some questions. So let's start on with number 2, find the derivative of this function. In two ways. So what we're going to do is we're going to use the quotient rule and then we'll check our answer with the power rule. So if we use the quotient rule, we would do f prime of x first, which is 4x cubed minus 15x squared. And then this, for now, we're going to substitute it in with x 1/2. So for that is going to be 1/2 x minus to the minus half power. And then that is multiplied by x squared, and we subtract that by x fourth minus 5x3 plus x to the 1/2 power, and then g prime of x, which is 2x, and all of that is going to go under x squared squared, which is just x to the 4th power. So now if we simplify the numerator, we could write it out here, down here, so we would have 4x to the 5th power minus 15x to the 4th power plus half times x to the 3/8 power minus 2x to the 5th power minus, or this is plus 10x to the 3rd power minus 2x to the 3/2 power. Now let's simplify and combine like terms. So let's start with 3/2. We have 1/2 and then -2. So we have -3/2 x to the 3/2 power. And then so we cross that out. Next is to the power of 3. We have 10x to the power of 3. And then we have a -15 to x power of 4. And then 4x5 minus 2x5, we have a 2x to the power of 5. So let's rewrite our equation right here. So we have -3/2 x 3 to the power of 2 plus 10x3 minus 15x4 minus 2x5 over x to the 4th power. Now, if we simplify all that, let's put it in this little bracket over here. So if we simplify that with like the denominator, we would have -3/2 x to the -1/2 power plus 10x to the -1 power. And then, oh, this would be actually a -5/2 because 3/2 over x4. So be -15. And then this would be minus 2x. And that would essentially be your final answer. You could also put it in a form in which there aren't any negative exponents. All right, so let's try out these questions. So let's try number 9, 11, and 13. And maybe 14, but probably not. So number 9 is y equals x over e to the power of x. So if we use the quotient rule, we do f prime of x, which is 1, e of x, e to the power of x, and then minus x times e to the power of x. And all that would be over e to x to the 2nd power. So if we simplify that, we would get e to the power of x minus x e to the power of x over e to the 2x power. in which we could simplify that, but a lot of the times you could just leave your answer like that, and that's just a viable answer. Let's try number 11. So number 11 is g function of t. So f prime is -2 and then 5t plus 1 and then minus 3 3 minus 2t and g prime, which is 5, and then all that would be over 5t plus 1 squared. So if we simplify that, we would get -5 or negative 10t actually, then -10t minus 2, and then that would be subtracted to -15 plus 10t over 5t plus 1 squared. And we will combine like terms here, in which we'll just be left with -17 over 5t plus 1 squared, in which this could be our final form answer. A lot of the times you don't need to simplify out the denominator because there's really no point in doing that since it won't give you a smaller answer. So let's now go to number 13. So number 13, f prime is 5, and then g is t cubed minus t minus 1, and then minus 5t times g prime, which is 3t squared minus 1. And then all that will, for now, we'll just write g of x squared, because that's a pretty long function, polynomial to write out there. So if we simplify all of the numerator out, we get 5t cubed minus 5t minus 5 minus 15t cubed plus 5t. So if we cancel out like terms, we get that, and then we'll end up with 10t cubed minus 5, or -10t cubed minus 5 over g of x squared. In that case, you would need to write t cubed minus t minus 1 squared, but you could just like leave it like that, and that would be your final answer. All right, so I want you guys to try number 24, 27, and 29. So you could try that out, and then you could pause the video and try that out. All right, so number 24 is the function h of r, and one thing to note is that a and b are constants in this function, and we're finding a derivative in respect to r. So if we use the quotient rule, we would do a to e to the power of r is just ae to the power of r times b plus e to the power of r minus ae to the power of r times g prime, which is just e to the power of r because b gets canceled out. And then that would be over b plus e to the power of r squared. If you simplify that out, you get ab e to the power of r plus a 2 e to the power of r. And then that would be subtracted by a 2e to the power of r. And yeah, that would be your only thing right there. Now, since this is negative, this is positive, we could cancel those out. And your numerator final answer would be a b e to the power of r over b plus e to the power of r squared. And that's your final answer. Now, number 27 is f of x. So f prime is going to be 2x e to the power of x times x squared plus e to the power of x minus x squared e to the power of x and then g prime, which is 2x plus e to the power of x. And then on the bottom is x squared plus e to the power of x to the power of 2. Now, if we simplify the numerator, we would have 2x cubed e to the power of x plus 3x e to the power of x. And then we would subtract that by 2x squared e to the power of x plus, or rather actually minus, x squared 2x squared e to the power of x. And now all we need to do is combine like terms. The first one's actually 2x cubed e to the power of x. So now if we combine like terms, we would have those cross out, and then these would stay here, in which we would be left with 3x e to the power of x minus 2x squared e to the power of x. And that would be all over x plus e to the power of x squared plus e to the power of x over 2. To the second power. That would be your final answer for number 27. Now, number 29, when we use the quotient rule, f prime would be 1 times g, which is x plus, and for this scenario, c over x, we'll rewrite that as cx to negative 1 power. That would be cx to negative 1 power, and then subtracted by x times g prime, which is 1 plus, or rather negative 1 c to the x negative 2 power. And all of that would be over, for now we're going to mark this as g of x, so I don't have to write all that out. So g of x squared. So if we simplify all that out, we get x plus cx to the negative 1 power minus x plus cx to the negative 2nd power. So now we would just cross out the x's, and we would be left with c over x plus c over x squared. All that would be over gx to 2nd power. And that would be about your answer for number 29. So I hope you guys, got the quotient rule. So it is a bit long and tedious like the product rule, but you could also, use the power rule by using the negative exponent form. But the quotient rule, you want to have all your stuff organized so you don't make a mistake, and take it slow so you don't make a mistake. You saw a lot of times here I got a little confused with whatever I was writing, but a lack of space was also a factor in it. But yeah, oh, you got to remember the formula of the quotient rule, and it'll be pretty easy to use as long as you also know what you're finding d over d in terms of. So if you know what you're finding the derivative in terms of, the equation also becomes a lot easier to understand. So yeah, that's basically it.